Batteries are everywhere. In your mobile phone, wristwatch and TV remote. They come in many different forms, such as the lithium-ion and the Leclanche cell. They can be used in specifically one appliance, or be universal and used in many. But despite how common they are, very few people know how they work, how they store hours worth of electricity in such a small container, and what happens when they run flat. In order to understand this, let's have a quick recap on electricity. Most electricity is caused by the flow of tiny negatively charged particles called electrons. These flow around the circuit and supply energy to any component that is connected. A battery produces these electrons by a series of redox reactions and then pushes them around the circuit. Now, let's take a look inside this common household battery. Within its outer shell, the battery consists of a metal and an electrolyte gel. These are separated by an insulator, for example paper, which prevents the flow of electrons between the two. Graphite electrodes are also used to provide efficient electrical conduction. The flow of electrons starts in the metal compartment, where a metal, in this case zinc, oxidizes, forming zinc 2+. This releases 2 electrons, and as more and more zinc atoms ionize, more and more electrons are released. And as they build up, they produce an overall negative charge in this compartment. Meanwhile, in the gel electrolyte compartment, a reduction reaction happens. Here, manganese dioxide reacts with ammonium ions and 2 electrons to produce ammonia and manganese oxide. This uses up electrons, producing an overall positive charge. You then end up with a battery split into 2 regions. One is positively charged, where electrons have been used up, and one negatively charged, where they've been produced. This causes the electrodes to become oppositely charged, forming a negative cathode and a positive anode. And if you connect the two with a wire, electricity will flow. This is because the many electrons in the negative compartment repel each other, pushing each other along the circuit. And as they get closer to the positive electrode, they are attracted to it. This causes the flow of electrons from the negatively charged zinc compartment to the positively charged gel electrolyte. Normally you hear that electricity travels from the positive terminal to the negative terminal. This is called conventional current. However, the flow of electrons is actually in the opposite direction. Now, as electrons leave the negatively charged zinc compartment, they are replenished when more zinc atoms oxidize. And as they arrive in the gel electrolyte compartment, they react with magnesium dioxide and ammonium and are used up. This maintains the gradient of charge and allows the battery to go on for hours. Eventually, all of the zinc atoms have ionized and all of the manganese dioxide has been used up. This causes the battery to run flat. However, if you have a rechargeable battery, you can undo this. These batteries work by reversing the overall reaction. Zinc ions are supplied with electrons, forming back into zinc, and the gel electrolyte reaction reverses, meaning magnesium dioxide is reformed. And once fully recharged, the battery can work the same way as before. Now, different batteries will use different reactions, but the overall concept is the same. So, next time you power up your phone or check the time on your watch, remember the small but powerful component within that allows you to do so.